Hello, this is the Hertfordshire and Essex High School and Science College. Welcome to Year 12 Virtual Induction. This is the A-Level Computer Science Induction for Herts and Essex High School. And what we'll be looking at today is course information, and we'll also be delivering a taster lesson for you.
Hello, my name is Mr. Bowen, and I will be starting my third year at Herts and Essex. I have been teaching computer science and IT for over 10 years, having previously taught at other schools in Hertfordshire and Essex. Before that, I worked within the IT industry, specifically for Tarmac, where I worked there for approximately 10 years as well.
Hello, my name is Miss Williams. I'm the subject lead for computer science. I've spent 20 years in industry in various IT and computer science roles, and I have been at Herts and Essex for 6 years and have been the subject lead for 2 years. So we decided to ask our current Year 12 cohort of students to provide some feedback on some questions that we asked them. And we've also got some short clips from students who were previously at Herts and Essex. Question 1 was, why did you decide to do A-Level Computer Science?
Hi, my name is Remy. I used to be an A-level computer science student, H&E, and then now I'm a first year chemist at Durham. Why did I decide to study A-level computer science? It was because I wasn't sure if I wanted to study computer science at uni, or if I wanted to study a couple of other things.
From a young age, I've really been interested in programming and was pretty certain that's what I wanted to study at university, and saw the A-level as a way of making sure that's really what I wanted to study whilst gaining some of the core knowledge that you need to study computer science. And whilst it's not required, it's definitely useful.
I decided to do A-Level Computer Science as I've been really interested in computing for a while, and I really enjoyed doing the GCSE. I'm also planning to do a job in computing in the future.
We then asked, what was or is your favourite part of the A-Level course? Please pause the video at any point to read the slides.
My favourite part of the A-Level course was the programming project, because you have lots of complex code, but it starts off simplistic and just builds up over time, which makes it a lot easier to manage because you understand what you're actually doing. You also have lots of control over what you do and how you want to do it, meaning it's possible to do things that are not available on school computers and potentially not even taught on the spec.
What's my favourite part of the A-level course? I like doing the project now it's finished. I was not a huge fan of it at the time because I left all my work until the very end.
I think my favourite part of the course was also my least favourite part of the course, and that was the independent project. It's a lot of work and a lot of independent research, but you get to work on what really interests you, and you can pick pretty much whatever you would like to do.
The next question we asked was, why did you decide to study at Herts and Essex? Please pause the video at any point.
Why did I decide to study H&E? Because it is kind of the best school that you can get to without doing any significant amount of travelling if you live in Stortford.
I decided to study at Herts and Essex because I looked at the difference between the AQA and OCR course, and I found that I prefer the AQA spec.
I think there were two main reasons. One was certainly the impressive grades that they often achieve at Herts and Essex, but also the friendliness of every single member of staff and all the students that I met on the visiting days. And throughout my entire time at Herts and Essex, every single member of staff that I met, I felt like they truly cared about your progress and just how you were doing.
One of the questions we asked was, what advice would you give to someone wanting to study computer science at Herts and Essex? Please pause the video if you'd like to see the slides for longer.
There's two main pieces of advice that I would like to give you, and that is to start your project early and to choose something that really interests you so that you want to work on it. But also to not just learn the content that's required for the course, but to read around the subjects that you're learning about, because I think it will make you find the subjects more interesting, but it will also be really useful in the future if you go on to study computer science.
If you decide to study computer science, make sure to start your projects early, especially the paperwork side, and if possible, get a laptop because that makes it easier to do projects in class and in your frees. Also, doing maths for another A-level, even if that's core, does help because a bit of A-level maths comes up and it's easy to remember if you can link it in with the other A-level maths that you've been taught.
What advice would I give to someone who wants to study computer science at H&E? Kind of the project has a pretty, there's a lot of time in which you can do the project. Don't leave it till the last minute. And also do coding practice. Do so much coding practice.
The final question we asked was, how has A-level computer science helped you since leaving Herts and Essex?
Since leaving Herts and Essex and completing my A-levels, I've been studying computer science at the University of St Andrews, and the computer science A-level has really helped me get a good start at university. And a lot of the content that you learn about might not seem that relevant, but everything that you learn about is relevant to some aspect of computer science and really helps in the future to just get that basic level of understanding of a certain topic.
Computer science helped you since you left H&E. No, first year chemists apparently know how to use a computer, so I ended up doing a lot of Excel work, and I have to do it very quickly, and having done computer science definitely helps with that. And I'm doing a computational science module next year, which I think I'll have a leg up on because most people who do chemistry stop doing computing at before GCSE.
So, why should you do A-level computer science? We think you would really enjoy this subject if you've enjoyed completing GCSE Computer Science and have achieved a good grade. We also think it's beneficial if you enjoy coding and want to tackle more challenging coding activities, or you enjoy logic puzzles and games, for example, Sudoku, or are fascinated by puzzles on the GCHQ Twitter page. Also, if you enjoy playing computer games and wonder how they work and how they're programmed. Further, if you want a subject that complements other sciences, maths, or just want to take the subject for the sheer enjoyment of coding and learning about computers. Or you want to be challenged and want to continue learning a subject which teaches you how to logically and critically think. At Herts and Essex, we've been very fortunate to secure some outstanding destinations for our students. As you can see, many of our students who take computer science go on to study that at university, and we've been successful in placing students at the University of Surrey, Manchester, Cardiff, St Andrews, and also Durham for physics, Durham for chemistry, and Royal Holloway for computer science and cybersecurity, University of Bath for maths, University of Leeds for computer science, University of Warwick for computer science, Oxford Brookes for cybersecurity, SOAS for Japanese, and we've also had students successfully take up apprenticeships with both GCHQ and also pharmaceutical companies. These are the skills that we believe that you will gain and develop from A-level computer science. So we're very clear that you will improve your coding and your programming skills. We often work as teams within the group. We believe that resilience will be increased. As part of the project, your time management will improve, as will your organisational skills. We also think that because you present your project, that will enhance your confidence, and your teaching skills will also improve because of the work that you will do with lower school students. In your project, we believe that you'll be creative, and we also believe that you'll have to employ strategic thinking and logical thinking to develop those activities. As part of that, you'll also have to employ project management skills, and further on in the project, you will develop analytical, design, and evaluative skills. The course that we follow at Herts and Essex is the AQA 757 course, and the programming language we use is Python, and the version that we use is Python 3 or above. So the course covers the following areas, which should be familiar to you if you studied the GCSE OCR course or the GCSE AQA or edXL course. So we look at fundamentals of programming. So we develop your programming skills, and that includes object-oriented programming. We also look at data structures and algorithms. We also examine theory of computation, data representation, computer systems, computer architecture and organisation, and the consequences of using computers. So that's really looking at ethics and legal frameworks. Further, we do quite a big focus on databases, which is probably something you've touched on in your GCSE course. We also look at big data and how that affects organisations worldwide. And following on from that, we complete activities on functional programming. Your programming is designed to ensure that you can successfully complete your programming project. So the final assessment for the A2 paper in the AQA 7517 scheme of work is broken down into 2 papers, which are 2 hours 30 minutes each. So paper 1 focuses on topics such as fundamentals of programming, fundamentals of data structures, fundamentals of algorithms, theory of computation, problem solving, and also gives you the opportunity to demonstrate your programming skills in the exam. This will be an unseen question that relates to a problem which you have not seen before and you have to program a solution to. And the other aspect is a skeleton program which has been provided to you in the September of your Year 13 course of study. It's then up to you to develop your skills in that skeleton program so that in your final assessment you can perform highly. Paper 2 is 2 hours 30 minutes and covers topics including data representation, computer systems, computer architecture and organisation, legal and ethical frameworks, databases, big data and functional programming. The final part of your assessment is the non-exam assessment, and this contributes 20% of your overall mark. And this is a non-exam assessment which assesses your ability to program a solution or to solve a problem or to investigate a practical problem. You'll be expected to follow a systematic approach to problem solving, and you will also have to employ analytical skills within this and design skills to design a suitable program and solution, and also evaluation skills. So this piece of work has to be handed in to your teacher before the Easter of your Year 13.
Hello, I'm Mr. Bowen, and I will be one of your teachers should you decide to join Herts and Essex. I have been teaching computer science and IT for over 10 years, and before that I worked in the IT industry. I am now going to run through an example on the AQA A-level specification. The example that I have chosen is Dijkstra's shortest path algorithm. So Dijkstra, he was a Dutch computer scientist and published this algorithm in 1959. And it has a very practical use because it is used to calculate the shortest path between two places, and is used in sat-navs to find the best route, and also computer networks to route data packets. Here we have two maps of how you would get to Herts and Essex from the station, one by walking and one by car. For each route there are many options, and the shortest route is not always the quickest. On a car journey, SatNav is constantly updating, taking into account traffic conditions. It does this by adding weight to each road. The lower the weight, the quicker the journey. Okay, so this is how we would represent the route graphically. So it's a very simplified version. The letters, they represent something called nodes, okay, and the lines, they're called edges or arcs. Okay, so the nodes, they can represent towns, something like that, and the lines would represent the roads. Now there's also the numbers. The numbers is the weighting that we talked about earlier. Now the numbers don't always have to represent distance, it can represent cost. I'm now going to run through a worked example of how we would calculate Dijkstra's shortest path. In this example, we want to get from A to J. Okay, so we want to get from point A to point J. So the first thing that we need to do is we need to put a 0 next to the A, because from A to A, it costs us nothing. Then we want to put a box around it to say that, right, that is held. We have finished with that. It will all come clear later on. So now from A to B, that's going to cost us 4. So we put a 4 next to it. From A to D, that's going to cost us 8. So we put an 8 next to it. And from A to C, that's going to cost us 5. So we put a 5 next to it. Now we look for the lowest number. The lowest number here is B. So we're going to start at B now. So from B to E is 4 plus 12. So that's going to give us 16. Okay, so 4 plus 12, that's going to give us 16. We've put a box around the 4 to say that we are now done with B. We are on B now. From B to D is going to be 4 plus 3. 4 plus 3 gives us 7, which is lower than the 8. So therefore, we cross out the 8 and we put a 7 there. We have now finished with B. So we're now looking at the lowest number again that we haven't already done. So you've got the choice between 16, 7 and 5. So we're now going over to 5. Put a box around it to say that we're starting at 5 now. And so from C to D, it is a cost of 6, which is lower than 7. So therefore we cross out the 7 and we type in and we write in 6. From C to F, 5 plus 11 gives us 16. We haven't used this already, so we just write 16 next to it. So we've done all routes for C. So now we look again and find the lowest number. The lowest number is 6. So we're starting at 6. 6 plus 9 gives us 15. So from D to E, it's 15, which is lower than 16. So we cross that out and we write in 15. We're still on D now, so from D to G, it gives us 10 plus 6, so that gives us a value of 16. And from D to F, we've got 6 plus 4, which gives you a value of 10, which is lower than the 16 that is already there, so we cross that out and we put 10 next to it. So now we're looking at the next lowest value again. Next lowest value again is this 10 here, so we're going to start at this number 10. Put a box around to say this is the one that we are working on now. So 10 plus 5 gives us 15, so which is lower than 16, so we cross that 16 out and we put 15. 10 plus 11 gives us 21, so we write 21 next to I, nothing to cross out because it's already there. That's all roots from F completed now, and so again we're looking at the lowest number. We've got two 15s, doesn't matter in the slightest which one you choose when there's two, it doesn't have to be the top, it doesn't matter. So we're going to start with E. So E, so we're on E now, so from E to H, 15 plus 10 gives us 25, nothing written there. From E to G is 15 plus 6, which equals 21. Now, we don't write that 21 down, okay? We do not write 21 down because it's higher than the 15 is there, so we just ignore it. So now we are done with E. So we're looking at the numbers, so we're starting at G now because G is the next lowest number. So we put a box around G. So we're going from G to H. 15 plus 3 gives us 18, so we cross out at 25, we write 18 next to it. G to J, 15 plus 15, 30. G to I, 15 plus 5, 20. So we cross out the 21 and we put 20 next to it. Not long to go now. Next lowest is 18. So 18 plus 14 gives us 32. Of course, we don't write that down because 32 is higher than 30. We've finished with H now, so we go into I. This is the last one. So I to J, 20 plus 8 gives us 28. And therefore we reach the end. So the shortest path has a weighting, lowest weighting. It's going to cost us 28 to get there. That is the lowest we can do. So what we do now is we work backwards to find out what the journey would have been. So the journey would have been J. So we'd start off with J. So 28 minus 14, okay, gives us 14, and that's not the same as 18. So it's not that way. Okay, so 28 minus 8 equals 20. So therefore we're going from J to I. Okay, so 20 minus 11 does not equal 10, so it doesn't go from I to F. So it goes, so 20 minus 5 gives us 15. So it goes from J to I to G. 15 minus 5 gives us 10, so it means we must be going to F. 10 minus 4 is 6, so we go to D. 6 minus 1 is 5, so we must be going to C. And then finally up to A. So the path is A, C, D, F, G, I, J. Okay, so now it is your turn. It's your turn to have a little go at working it out. So this will be a good opportunity to stop the video and to see if you can work it out. I have put the solution right at the end of this presentation. Now within the exam, this is how the type of exam question you will get. So this is taken directly from a past exam paper. So it says Fig 6.3 is a graph representation of the places that a travelling salesman visits. Using this graph, show how Dijkstra's algorithm would find the shortest path from place A to place F. And then you'll just work through that. As promised, we have the solution to the problem that I posed you. The shortest path you should have come up with should have been from A to C to B to E to F and then finally to G. Thank you for listening. My name is Mr. Bowen, and I very much look forward to seeing you in September.
So at the start of every lesson, we begin a lesson starter. And what I've designed today is a starter which is a logic puzzle. So you can see if y plus y equals b, y plus g equals b, r plus b equals g, and g plus b equals b, then what is r plus r? You might want to stop the video and then I'll give you the answer. So the lesson starter answer is as follows. This actually relates to a game of snooker. So using the information, you should be able to work out what all the equations work out to. So we have yellow plus yellow equals brown. Yellow plus green equals blue. Red plus pink equals black. Green plus brown equals black. And red equals yellow. This is very, very typical of the type of questions that we give at the beginning of the lesson. And now Mr. Bowen will take you into Dijkstra's algorithm. Hello, thank you so much for watching the video today. I know it's not the same as meeting people or having that personal experience. However, we really hope you found what we've produced useful. If you'd like to get in contact with us, please do. We've provided some email addresses for you. So if you have any questions at all, please do not hesitate to contact us. Thank you very much for watching, and I really hope we get to see you in September 2020. Thank you for listening and watching the Computer Science Induction. We really hope you found it useful. We look forward to seeing you in September 2020.